If P then Q is also called as implication of P and Q, that we usually write it as P implies Q like this or using this. Double implication means it is acceptable from both sides. The converse of a statement is very necessary in mathematics, especially in geometry. Contradiction. It is actually a method to verify whether a statement is true or false. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in our previous session, we have studied about mathematical logic and the terms related to it. We say any statement is acceptable mathematically when it is either true or false. A statement cannot become true or false same time. So therefore, we have also learned the statements used connected from the word and or. So in today's session, we are studying the statement which contains the phrases like if then, if and only if. Also, we will study the converse and contrapositive of a statement and the contradiction method of proving the results. So let's study the first one, if P then Q. So in mathematics, we come across many type of statements. For example, if all sides are equal, the triangle is equilateral. If opposite sides are equal, then the quadrilateral is a parallelogram or a rectangle. Like this, we come across a connecting statement between the two statements using the phrases if and then. So now, it is also a compound statement because it is made up of two or more statements. So what does if then Q statement says? So if P then Q is also called as implication of P and Q, that we usually write it as P implies Q like this or using this. So this is how we denote a statement which is a implication. So now let us see how it is arranged with respect to the rule. Now if we take two statements, P and Q, so their truth values are assigned. If both are true, the statement is true. If the first statement is true, second statement is false, then the P implies Q is false. And false true combination true, false false combination is true. So when P implies Q is true, it is true when both are true, both are false, first statement false, second statement true. So it is false only in the case if P is true and Q is false. So when any statement containing if then statement will become false only in the case the first statement is true and the second statement is false. In all the other cases, it is considered as a true statement. So the next statement is P if and only if Q. So where we use this if and only if Q. For example, we can come across the mathematical statement where we say it is a square if and only if all sides are equal. Or that means we can also say if all sides are equal, then it is a square. So whenever two sides complements to each other, there in that such situation, we use the word P if and only if. So this is also called as double implication of P and Q. We denote it by P double implication Q. That means it is true from both sides. If P is false, then Q is also false. If P is true, then Q is also true. So that the compound statement containing P and Q is also true. So therefore, the rule of if and only if says that if both the statements are true and if both the statements are false, we conclude the compound statement is true. And in other cases, it is considered as false. If one statement is true and the other statement is false, we take the double implication as a false statement. It is true only if two statements are true or two statements are false. Next we have given below are two pairs of statements combine them using if then. So here we have a quadrilateral is a parallelogram if its diagonal bisect each other. So a quadrilateral is a parallelogram if its diagonal bisect each other we have. So we have to write using the word if then. So how to connect these kind of statement? So how we will write? If a quadrilateral is a parallelogram, then its diagonals bisect each other. So this is how we can write connecting the statements. Next, the banana trees will bloom if it stays warm for a month. So if banana trees will bloom, then it stays warm for a month. So like this, we can also connect the statement using and, or, if then, if and only, if then also. Next, given below are two pairs of statements, combine them using if and only if. The first statement is, if a rectangle is a square, then all its four sides are equal. So how to write? If all the four sides of a rectangle are equal, then the rectangle is a square. So here P is one statement, Q is one statement. I said it is acceptable from both sides. So here P is combined with two statements. That is, a rectangle is a square is one statement. All four sides are equal is another statement. Similarly, the Q statement is reverse of P. That is, all four sides of rectangle are equal, then the rectangle is a square. So this is how we will connect the two statements. Now we have to use if and only if statement. So how to use this? A rectangle is a square. A rectangle is a square. If and only if all four sides are equal. So this is how we connect two statements. So here the same statement is written exactly vice versa. So therefore we will combine them to make a single statement using the word if and only if. So this is how we connect all those phrases. There exist, for all, if and only if then, and, or to combine the statements. So next we come across a very important concept, that is converse. The converse of a statement is very necessary in mathematics, especially in geometry. So here, what is this converse of a statement is? It is purely for the implication statement. Implication statement means if then statement. So for example, if a quadrilateral is a square, then all four sides are equal. So I have taken an example here. A quadrilateral is a square is one statement, that is P. I'll take it as P. And all four sides are equal is another statement, that is Q. And here it is saying if P, if this is possible, then it has to be. So that is, this is implication. So P implies Q gives you an implication. Suppose you write the statement as Q implies P. That is what the converse of a statement. That is, if all four sides are equal in a quadrilateral, then it is a square. So this is how we write the converse of a given statement. So whenever the implication is given from P to Q, then you have to write the statement vice versa. That is, we have to write it in the form of Q implies P. Next, the contrapositive of a statement. Again, this is also one of the important conversion of a given statement in the form of P implies Q. So if any condition is given in the form of if P implies Q, then we have to write not P implies not Q. For example, I'll take, so if students take good marks, then the questions are easy. The questions are easy. So here, the students take good marks is one statement. That is, I'll take it as P. And the questions are easy. That is another statement, Q. And we are connecting it with if then. So it is the implication statement. That is, P implies Q. If students take good marks, then questions are easy. If you write vice versa, if questions are easy, then students get good marks. That is the converse. Now what about contrapositive? Contrapositive is you have to negate both the statement. That is, you have to write not P implies not Q. So how to write not P? So if students do not get good marks or do not take good marks, then the questions are not easy. So this is how we will write the contrapositive of a given statement. Let's see a few examples and try to write the converse and contrapositive for the given statements. Write the contrapositive and converse for the following statement. So the first one is, if a triangle is equilateral, then it is isosceles. Let's write contrapositive. So contrapositive means you have to negate both the statement. So let's negate it. If a triangle is not equilateral, then it is not isosceles. So this is the contrapositive statement. Let's write converse. Converse of this statement is, if a triangle is isosceles, then it is equilateral. So this is the converse of the given statement. Next one, if x is a prime number, then x is odd. So given statement is x is prime number, x is odd. So contrapositive. So contrapositive, negate both the statement. So if x is not a prime number, then x is not odd. So let us write converse. So the converse of the statement is vice versa of the given. So here, if x is odd, then x is a prime number. So this is the converse of the given statement. Next, if a number n is even, then n square is even. So let's write contrapositive. So here, if a number n is not even, then n square is not even. So this is the contrapositive, converse. If n square is even, then n is even. So like this. Next one. x is a even number implies that x is divisible by 4. So x is not even number. So here the word implies is used. So instead of implies, you have to use if-then condition while writing contrapositive and converse. So we have to start the statement with if. So now if x is not an even number, we are writing contrapositive statement. So we have to negate the statement. If x is not even number, then x is not divisible by 4. So this is a contrapositive statement. Let's take the converse, that is reverse the statement. So if x is divisible by 4, then x is even number. So this is the converse of the statement. Next, if the two lines are parallel, then they do not intersect in the same plane. So let's negate it. So first, if two lines are not parallel, then they have given they do not. So if you have to negate it, then you have to write they intersect. So then they intersect in the same plane. So negation means if the statement is given with not, we have to write without not. So they have given they do not intersect in the same planes. We have to write they intersect in the same plane. So this is the contrapositive. Next is converse. Let's take converse. If two lines do not intersect in the same plane, then they are parallel. They are parallel. So this is the converse of the above statement. Next, here we have a contradiction. It is actually a method to verify whether a statement is true or false. Suppose we have to show that P is true. So here contradiction means taking exactly opposite. So we assume P is not true. So if we assume P is not true, after some certain step of verification, we will get the result is false. So if the result is false, that implies our assumption is also false. So our assumption was P is not true. So therefore, that is the contradiction method says our assumption is wrong. Therefore, the given statement is true. If we have to prove the given statement is false, we assume it as true, and by certain verification, we will get the result as false again. So there also we conclude our assumption is wrong. Therefore, the statement is false. Like that, we will verify whether the given statement is true or false by assuming exactly opposite to the truthfulness of the given statement. So this method is called as contradiction method. So here we have taken an example to prove whether the given statement is true or false by the method of contradiction. Let's look at the problem. Verify by the method of contradiction that root 7 is irrational. We have to verify that root 7 is irrational. Root 7 is an irrational number and it is a true statement. So we take it exactly opposite. So assume that root 7 is rational. So if root 7 is rational, it has to be satisfy certain condition. What is that condition? Let's see. If root 7 is a rational number, then it can be expressed in the form of P by Q, where P and Q are integers. P and Q belongs to Z. And the HCF of P and Q must be always equal to 1. Now square on both sides. So we will get 7 is equal to P square by Q square, or we get P square is equal to 7 into Q square. So let's take this as equation 1. So according to equation 1, this implies 7 divides P square. If any number is dividing its square, then it also divides the certain number. So it divides P. If 7 divides P square, then 7 divides P. So therefore, P can be written as a multiple of some 7 into other number. Let me take it as 7 into R. So where R belongs to set of integer. Now square on both sides. So square this equation. So we get it as P square is equal to 49 R square. So take this as equation 2. So observe equation 1 and equation 2. Equation 1 has P square is equal to 7Q square. Equation 2 has P square is equal to 49 R square. So if you substitute here in the place of P square, so we will get it as 49 R square is equal to 7 into Q square. So here we can divide. So 7 R square is equal to Q square. So from this, we can say 7 divides Q square. So this implies 7 divides Q. Observe this statement, 7 divides P as well as 7 divides Q. That means the common factor or the HCF of P and Q is equal to 7. Because 7 divides both P and Q. But what is our assumption? It is a rational number. If it is a rational number, then HCF of P and Q must be equal to 1. But we are getting HCF of P and Q is equal to 7. What does that implies? Our assumption is wrong. So our assumption is wrong. So what was our assumption? I have taken it as assume that root 7 is rational. So therefore, what must we conclude? So therefore, the root 7 is irrational. If it is rational, then it has to obey the rules of all PQ is equal to 1. But we are getting the HCF of PQ as 7. So therefore, whatever I have taken, the statement itself is wrong. So the given statement was true. What was the given statement? That is, root 7 is irrational. So this is how we prove certain statements in mathematics using the method of contradiction. So this is the method of contradiction to prove the given statement is true. So this is all about the chapter Mathematical Logic. We'll meet you in the next session with the new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.